Hello, today I will be going over the science section of the academic decathlon. So today I'll be going over section 1, electricity charged particles. A brief history of the atom. For millennia, people observed that rubbing certain materials caused them to stick together. So for instance, when you rub your hair against a balloon, it causes your hair and the balloon to stick together. This force was named electric force by William Gilbert in 1600 while experimenting on amber. The Greek word for amber is electron. In Western society, the prevailing thought was that all things on Earth was made of earth, air, fire, and water. And this is very similar to Avatar, where Aang was able to control all four elements. Um, and today we have the periodic table to learn all about the elements. For example, water is made out of hydrogen and oxygen. Reminder, you should drink your water, okay? And then lastly, the elements on the periodic table are not truly fundamental, as they are made up of smaller pieces. These smaller pieces are known as atoms. This is a diagram of an atom right here. So each of the elements on the periodic table is made out of a different kind of atom. In Greek, the word atom means indivisible, meaning that it is the smallest thing and cannot be divided. Philosophers argued that matter is infinitely divisible, while others think the smallest thing can't be divided. Benjamin Franklin's electrical fire. This is a picture of Benjamin Franklin and his kite and key experiment. As you guys might know, Benjamin Franklin is on the $100 bill. He is a famous founding father of the United States. He helped draft the U.S. Declaration of Independence and was a French diplomat. Franklin was also heavily involved in science. He read about the Leyden jar, which was an invention which stored electricity and shocked anyone who opened it. This invention sparked his curiosity in electricity. Franklin's electrical fire refers to the concept that electricity is like a fluid and would transfer between objects. One major thing that he figured out was that electrical charge is conserved and cannot be created or destroyed. This is just like energy conservation, where energy is conserved and it cannot be created or destroyed. Franklin also discovered that lightning was an electrical phenomenon through his key and kite experiment. This was groundbreaking news at the time. Electrons and protons. On the right here, we have a diagram of an atom. In the center, we have the nucleus. The nucleus is composed of both protons and neutrons. And on the outside, it is orbited by electrons. So, in physics, a particle is the fundamental piece of matter. Um, we can also say that in the nucleus, we have the protons and neutrons where they have the same mass. On the other hand, on the electrons have negligible mass, meaning that they have little to no mass. Mass is measured in kilograms, or kg. 1 kilogram is about the mass of 1 liter of water. Mass is also sometimes referred to inertia, which is the resistance to changes in motion. Electrons orbit the nucleus. Most atoms have an equal amount of protons and electrons. So, for example, oxygen has 8 protons and it also has 8 electrons. Uh, an element is defined by the number of protons. So, it's not defined by the amount of neutrons, it's not defined by the amount of electrons, it's defined by the amount of protons. Um, Protons do play a role in electricity, however, electrons play a bigger role. Neutrons are neutral, meaning they have no charge, and it's given by the name neutral neutrons. Both protons and electrons have the same amount of charge, but opposite, meaning that we have three positive charges right here. This atom has three negative charges for its electrons. Protons are positive, while electrons are negative, as stated before. Two of the same charge repel, while different attracts, which keeps electron in orbit. So same thing with magnets. The north attracts the south, and south attracts the north. But the two of the same sides repel each other. And finally, we're going to go into the laws of motion. The first law of motion states that an object's inertia will allow it to remain in motion as long as there's no external forces exerted on the system. So this basically says that an object will stay in motion as long as there's no force or anything else to that interacts with the system, and it will remain in rest as long as nothing interacts with the system. Force is measured in newtons, or also capital N. 1 Newton is about the weight of an apple. The second law of motion. The second law of motion states that force equals to mass times acceleration, where force is in terms of newtons, mass is in terms of kilograms, and acceleration is in terms of mass per second squared. Given this equation, a greater acceleration will cause a greater force, and a greater force will cause a greater acceleration. And our mass is going to be constant. So a more massive object will have a less acceleration. So a more an object with more mass will take more force to move it. And finally, the third law states that every action has an equivalent reaction. So force A exerts a force on B, then object B exerts an equal force back to A. For example, the sun and earth exert equal forces on each other. The sun is way more massive than the earth, that the acceleration is quite negligible. So that's why the earth and sun do not come close to each other and actually touch each other. Thank goodness. This is because one has more mass than the other, and the Earth has negligible mass compared to the Sun. That this does not happen. This is because of Newton's second law: force equals mass times acceleration. The more mass you have, the less acceleration you have. This is the same case for a proton and electron. A proton has a significantly greater mass. And this is it for this video. Thank you for watching.